Hi everyone, I am Orijit. On the behalf of my team, I would like to present our solution for this hackathon. Let's start. Our use case is IoT integrated P2P energy trading and token interchangeability. Now let's see what is P2P energy trading. P2P energy trading is where consumer can sell extra electricity generated by the solar panel back to the grid provider or to the community like any good or service. This helps the grid by reducing peak demand and reducing network loss. This use case is not new to the DLT world. We face some challenges for P2P energy, which stops this from large-scale adoption. Our solution addresses all those issues. As prosumers selling very small amount of electricity, the payment are also need to be small. As thousands of IoT devices working together, it becomes very difficult for DLT platform to perform real-time settlement with low transaction latency. And if tokenization is handled by a smart contract, then token interchangeability becomes the real challenge as user can't use this token for different services because it is belong to one platform only. If this P2P energy trading able to get large scale adoption, it will not only help the energy sector, it will also promote the renewable energy. Also, as the energy transmission loss is less for the P2P trading, this will help us to save electricity. This will also help us to empower our end user. We have two players for this use case. One is prosumer, one is grid provider. Now let's see who is a prosumer. Any individual or a company who has capability to produce electricity using solar panel can join our network. Second is grid provider. Grid provider is a grid providing organization or company or government body act as a regulator as well as prosumer. Buy sells energy if no other prosumer has demand or supply at that particular time. Now let's see what benefit our solution brings. It is distributed, efficient, trusted, and transparent. Now talk about the tech stack. We have used Hedera token service. This service is at the core of our application. This allows us to issue token to the customer at real time with very low latency. Next is Google IoT Core. It makes sure that all IoT devices responses are registered to the grid using MQTT protocol. Next is HCS service. It's help us to record the proof of energy delivery on DLT platform, which anyone can validate at any point of time. One question arises, why HTS for P2P? Because HTS enable us to do micropayment on real-time basis with very high throughput with low transaction fees, which help us to reduce operating costs. This is our architecture for this use case. You can see that IoT devices are directly interacting with the Google IoT Core, where Google IoT client is getting the messages and posting that to HCS to record the energy delivery. And later our application issuing tokens to the user based on the energy they have delivered. This is the tech stack we have used. We have used Node.js for the backend application, IoT Core for interacting with our IoT devices, MongoDB for off-chain DB, Google Hedera token service for user token management, consensus service provided by Hedera for proof of energy delivery, and React.js for prosumer dashboard. With the help of animation, you can see that our IoT devices are posting transaction to Google IoT Core. Then IoT Core topic client is posting the transaction to HCS to record the transaction on DLT. Then based on the HCS messages, our application is issuing some token to the user and recording that to DB. Now we will see our application to get idea how the things are happening. I will register a user here. Yeah, you can see the registration is done and it has provided all the details of private key, mnemonic, public key, and the account ID. We need to copy all the details as we require this for later storage and these details are not stored anywhere. Now on Google Cloud, we will start our service which will mock our all devices. So you can see it started transmitting messages every 5 seconds. So it has posted few transactions on Google IoT Core. So before we start our Google IoT client, we can check the message has been whether these are delivered to our Google IoT client or not by clicking on view message. Yes, we can see that the message has been delivered to Google IoT Core, and now we can start our Google IoT client. This was only for the verification purpose. This step is not required application. So now we will start the listener. This will receive all the transaction and post to HCS. Now I will start the process which will listen from the HCS and issue tokens to user account. It should start listening from HCS and started processing the transaction. Yeah. It has processed all those transactions and issuing tokens based on the amount they have submitted to the network. Now I will log into the user's account, newly created account. Yeah, we can see there 3 transactions has happened and the token he has earned, this amount he has earned. There was some initial balance to this account. So now let's search. So you can see there is a 3 transaction. The last transaction was he was received sold some amount to the other parties. For that he has received this amount of tokens, and for other 2 transactions he has requested some amount of electricity from other participants. So for that this amount was deducted from that from his account. Now we will see the withdrawal part. To convert the energy token into gaming token, now we'll click on withdrawal. We'll provide the amount withdrawal as gaming token. For authorizing, we need to provide the private key. Withdrawal and start it. You can see the transaction has is retrieved, and you can see the token has been decreased and gaming token has been provided to his account. 1:3 ratio, so you can see it has been issued to this account. Let's see the token calculation logic on our platform. If user generates more electricity or demands more electricity at once, the per unit price of the token increases. In the per token interchangeability part, one energy token represents the framing token. For our use case, we have implemented token interchangeability between 2 tokens, green energy token and gaming token. As both of them are on HCS, we can use them interchangeably for that token earned using energy trading can be used for gaming purposes, and this way we can use our token on different platforms. Now talk about the future roadmap. We can collaborate with different industries to implement the interchangeability where users able to use their token on different platforms. And for interoperability purpose also we can extend this token where where there will be a common account used for the all transaction, and different companies can use that. You can contact us at the below details, and you can also use our application at this URL using these credentials. GitHub code has been already shared. This video will be uploaded on YouTube soon. Thank you.